Theme parks around the world are places that bring magic and fun to life, and the main draw for most theme parks is their attractions. Universal Orlando, in particular, provides next level thrill rides, dark rides, and futuristic rides for the enjoyment of families and friends. Now, with how popular Universal Orlando can be, crowds are a nagging issue for many people visiting. Florida is ranked the top state in the U.S. by theme park attendance year after year, with Universal Studios Florida and Islands of Adventure, both Universal Orlando parks, ranking in the top 5. With the opening of Epic Universe back in May of this year, those numbers only continue to grow. Now, with these statistics in mind, and millions of guests visiting Universal Orlando every year, long lines are one of the biggest issues the parks deal with. But different rides handle crowds differently. Let me explain. Monsters Unchained: The Frankenstein Experiment is the new signature e-ticket attraction at Universal's Epic Universe, being the first ride in the park to hit 1 million riders. Now, with the raving reviews for this attraction and the crowds of people flocking to this ride, it may seem like you'd be lucky to ride it once in a day, but this couldn't be farther from the truth. Monsters Unchained consistently sees an average wait time of about 15 to 20 minutes on any given day, even on busier days. How is this possible? How is it that the most popular attraction in a brand new theme park that has amazing reviews has such short lines? The key is capacity. Capacity is the way that theme park attractions can get through lines quickly, and there are many ways of doing this. If we take the Monsters Unchained example, the way that they keep a short line is the combination of their loading system, high number of ride vehicles, and a constantly moving ride that doesn't stop, even when you are boarding. Now, in the case of an older attraction, like the Incredible Hulk coaster at Universal's Islands of Adventure, things are a lot different. They only have a few ride vehicles, a traditional station, and the ride operators are the key to their lines being shorter. Every dispatch at the Incredible Hulk coaster is manual, meaning every minute or so, the control booth operator has to press a button to dispatch, unlike an attraction like Monsters Unchained, which is constantly moving. Now, with a 32-passenger ride vehicle, Hulk definitely has the capacity to keep short lines if the team members operating the ride are quick. But if everything is going smoothly, where's the issue? The issue for a ride like Hulk, and many other rides like it, is empty seats. At Universal Orlando, empty seats are counted by the control booth operator via a clicker, and these can be easy to miss sometimes. This can be a problem, because every hour, Universal attractions must upload their dispatch and guest counts to an in-house data analysis team, which is also shared with executives at the company. If the control booth operators are consistently missing empty seats due to human error, how will the executives know that there are issues that need to be addressed? By using Six Sigma methodologies and quality engineering principles, we have put together a series of charts, phases, and checklists that can hypothetically automate this process, for example with sensors, to automatically count these empty seats and collect the correct data.
Building on that example, our project looks at what's happening behind the scenes in those dispatch operations, especially at rides like Hulk that depend on human operators. Research in operations and queuing shows that the real enemy is not average speed, it's variation. So, when cycle times jump around because restraint checks are slower in one train, row assignments are messy on the next, or the dispatch signal is delayed, waiting lines grow fast, even if things feel pretty quick on average. Studies on theme park attractions also point to the same issue. Non-standard procedures, inconsistent training, and human error are major causes of lost capacity. At the same time, reliability research shows that downtime and last-minute fixes disrupt the flow of guests and make waits feel longer and less fair. Our project uses Six Sigma and quality engineering tools like CTQs, process maps, and control charts to focus specifically on dispatch interval consistency. The idea is to support operators with clearer standards, checklists, and better data, so leaders can actually see when empty seats, slow cycles, or maintenance issues are hurting capacity and then fix those problems in a structured, data-driven way.
So Connor just walked us through why Universal's ride dispatch process matters so much for guest experience, and Fernando connected that to the literature on variability, human factors, maintenance, and Six Sigma. Together, their sections basically show that in high-demand service systems like theme parks, it's not just average speed that matters, it's how consistent the process is from train to train. Building on that foundation, my part focuses on the methodology we use to actually study and improve that dispatch process. We followed a Six Sigma DMAIC approach: define, measure, analyze, improve, and control. In the define phase, we created a project charter, a SIPOC diagram, and a high-level process map to set the scope, identify key stakeholders like operations, maintenance, training, and quality engineering, and clarify what success means in terms of safety and throughput. In the measure phase, we translated those critical to quality requirements into metrics like average dispatch interval, its standard deviation, seat fill rates, and data logging accuracy. That gave us a baseline for how stable the current process really is. The analyze phase then used tools like FEMA and control charts to pinpoint where variation was coming from, things like row assignment, restraint checks, and communication between platform operators and the control booth. Finally, in the improve and control phases, we used those insights to design standardized loading and signaling procedures, data-driven training, and ongoing monitoring with XBAR and R charts. So my methodology section walks through how this DMAIC structure turned the issues Connor and Fernando described into a concrete data-driven plan for making Universal's dispatch process more consistent and predictable.
Thank you, Sammy. Moving on from the methodology section, we now look at the results. Our results showed that dispatch operations at Universal Orlando attractions were not consistently stable under the current process. In the define and measures phases, we found that dispatch intervals varied widely, largely due to inconsistent guest loading, restraint checks, and communication between platform staff and the control booth. These variations directly caused longer wait times, lower ride throughput, and a less predictable guest experience. Using control charts, we compared the current as-is process to an improved to-be process. The current system had an average dispatch time of 85 seconds with high variation, meaning the process was statistically out of control. After applying Six Sigma improvements, the process stabilized around a 72-second average dispatch time, with much tighter variation. Capability improved significantly, and the defect rate dropped from about 90% to under 7%, showing that the new process was far more reliable and consistent. In the analyze phase, root cause tools like the FMEA table showed that most delays came from inconsistent row assignment, repeated restraint checks, communication gaps, and uneven training. These were process problems, not the staffing issues. The improve phase focused on three main solutions: standardizing guest loading and restraint procedures, improving visual and digital communication from the control booth, and using real-time data dashboards for targeted training and performance feedback. Finally, the control phase ensures the improvements last. Ongoing use of control charts, standard procedures, and real-time performance dashboards will help keep dispatch time stable, maintain safety standards, and continue reducing guest wait times while improving overall ride efficiency.
Thank you, Adam. Now that we walked through the results of our analysis, I'll be moving on to present the conclusion of our project. I'll be summarizing what our findings ultimately mean for Universal's attraction operation. Overall, this project examined the ride dispatch process with the goal of improving operational efficiency while maintaining the highest standards of guest safety. Our DMAIC approach, supported by tools like the SIPOC, PMAP, root cause analysis, the FMEA, control charts, and capability analysis, allowed us to clearly identify where instability and inefficiencies were occurring in the dispatch process. From our as-is analysis, we confirmed that the current dispatch system was not statistically stable. The control charts showed points approaching or exceeding the control limits, along with non-random patterns indicating special cause variation. The capability study further showed or demonstrated that the process was not able to meet operational targets. With a low CP value and a defect rate about 90%, these issues were primarily driven by inconsistencies, restraint check procedures, variability in guest loading and row assignment, communication differences among operators, and uneven training procedures. The improvements we propose show that meaningful gains are achievable when variability is reduced and standardized work is implemented. In the to-be state, the process displayed much tighter control limits, improved consistency, and slightly lowered variation. The average dispatch internal decreased, the standard deviation was reduced, and the defect rate dropped to approximately 6.68%, indicating the process became far more predictable and capable of meeting expectations. These improvements directly translated into shorter, more consistent wait times and increased throughput. Ultimately, your project confirmed the process consistency is the most important driver of operational performance in theme park ride systems. When safety procedures, loading methods, communication protocols, and training programs are standardized and continuously monitored, both efficiency and safety improve altogether. For this reason, we recommend Universal sustain these improvements through ongoing use of control charts, data dashboards, and structured training programs. Doing so has strong potential to maximize ride capacity, elevate the guest experience, and reinforce Universal's reputation for operational excellence.